Hi everyone, and this is Zhao Yangchen, and thank you for listening to my presentation. And also thanks to Dr. Silva and Tia Sun for the teaching of this semester. And my project is about spam detection. And I choose this project because it is very closely related to what we have learned and what we have discussed in this semester. Build an intelligent system and detect some text message and do the classification task. This is what I'm thinking about this project is doing. And so let's move on. So the first introduction part is to discuss the impact of spam message. In nowadays, nearly half of mails are sent to worldwide are still spam, and this kind of message including harassment, phishing, and sometimes will cause the personal property loss and even cause some mental loss for our users. And also this kind of message will increase the workload of the server and also waste some bandwidth from of the internet. And as for the challenge, this kind of message has very short message length with limited context. And also including this kind of message will including some abbreviation and informal language. Some kind of symbol, if you don't know what's meaning, you will think that is useless. But they may not be the harm or may not be the spam message. And also this kind of message are sent massively every day. Even for me, I will receive this kind of message and a lot. And as for the background investigation, there some researchers has already posed very effective models such as naive Bayes, SVM, logistic regression, and also some unsupervised learning models clustering such as KNN. And also because this is the field of natural language processing, and some deep learning models such as recurrent neural network and long-short-term memories has been used on this kind of detection tags. And for my investigation studies, I do have practice on the deep learning models, but because of the limited data resource, I found out that this kind of deep learning models performed not that satisfied compared with classical machine learning models. So back to my own project. My project is to focus on two tasks. The first one is to evaluate the performance of logistic regression and multivariate Boolean line-based NB classifier and support vector machine classifier and stacking models. The stacking models is the combine of three classifier. I choose two classifier as base models and I choose one classifier to do the final decision. And also for the task 2, I trying to evaluate the robustness of the models with different feature inputs. Okay, so this is what I'm doing in this project. So let's move on. And the dataset I use is from UCM Machine Learning repository, and the total instance of records is 5,572. And for the harm message, harm means use message, useful message is 4,825. And spam message means useless message is junk message is 747. And you can clearly see in this table, and this definitely you can just from your eyes to see the spam message, and this also a spam message. And as for data processing, I use 5 type of processing ways to do the data processing, and in layers each more stringent than the last. And as for the text one, I use I just tokenized the each words, and text 2, I just found the stem of the word such as watching to watch, and text 3 is on the top of text 2. That I remove some stop words such as I and here. And for the text 4, I remove the special words and keep the alphabet and numbers. And for the text 5 is to apply all of these constraints and find the very core and important words of each context. But we have to admit that if the text is only including symbols, these two ways for text 4 and text 5, these two ways will lost some information and return a null value. So we have to consider in practice. And also the feature engineering. For the feature engineering, I extract 3 new features from the original text data, which is the number of characters, number of words, and number of sentences. And clearly you can see this plot. There is some obvious difference between this two kind of message, and the red one is spam message and the blue one is a home message. You can see the difference on this plot. And also I do the vectorization. And vectorization is I've used 2 ways. One way is the TF-IDF and another way is count vectorizers. And because of the naive Bayes is Bernoulli naive Bayes, I use count vectorizer as a feature input. As for the extra 3 models, I use TF-IDF as a feature input. And so let's move on to the model performance. And the first performance is to classification accuracy with different text types, as we have discussed in above lecture and above sections. The text 1, 2, 3, 4, 5 is extra by different way, but the naive Bayes and logistic regression model are very robust and can also give you a satisfied classification rate. Especially for the number 4 and 5, we know we will lose some accuracy, but luckily for now, this is very, and actually I do think this is a satisfied outcome. And also because of the random selection, and every time if I change I use a cross and validation, each time the outcome will be slightly different, but the accuracy will be around as 98% or 97% each round. And also this is a model evaluation. As for the 4 models I built in my code, and the matrix is the first 5 is some matrix specifically evaluates the classification outcome, the accuracy, the precision, recall, and FE score, and also the time. The time is the training and is for the training time and also the predicting time. As we see, the stocking models has the best accuracy score and also the F1 score. And so I have to say the stocking model is the best of 4 of them. But he has a lot of time. He needs a lot of time to training and predicting. And as for the naive Bayes, the multivariate Louis, and logistic regression, and they performs also is better. I cannot say better is very good with 98% percentage accuracy, and also their time is very short, so they don't require many computer resource. And I do think these 2 models is very good, especially the naive Bayes classifier. As we all know, this kind of two algorithm are widely used in the real spam detection system. Yeah, so that's it. And thanks for your listening. And so then I will move on to the coding part, and I show you how to run the code. And so the first is the processing part is I can just run all, and this code will how say extract all the features and do the plot things and extract all the features and do the plot things. I think he's he's plotting the final table as we see with no ending errors, and this is for the processing part, and this is for the grid search, and the grid search will take some time to do so, and I cannot say how long it will take. Maybe 5 to 10 minutes will finish all the grid search part. And as for the so I hope you can see the code in detail in the project review and all of this code. The first one is processing and the second one is grid search. And the last two, the first is to text different tests. I'm trying to text the performance of each kind of models, and the text model is for the evaluation of different models. Yeah, so and this is a little bit confusing, but if you check to my report, and you will see very clearly, and what I write in this code is also very clearly and logic. Okay, so that's my presentation. Thank you so much. And as you can see, last minute, as you can see, the very good performance of each models, very good performance and very good FE scores, and then you can run the code by yourself, and you will see the quite very good outcome. Thank you.